When you update a Kubernetes deployment, you are not editing running pods by hand. You are changing the pod template, and the deployment controller replaces the old ReplicaSet at a controlled rate. The mental model is 3 layers. The deployment stores the desired rollout. Each revision is represented by a ReplicaSet. The ReplicaSet keeps the matching pods at the desired count. A deployment needs a selector and a pod template. In apps/v1, the selector is explicit and immutable, so plan labels before creating the object. After apply, check the deployment. Ready is available over desired. Up to date means pods match the newest template. Available means they pass readiness long enough to serve. The focused command is rollout status. It follows the current rollout and exits successfully when Kubernetes considers that rollout complete. A key docs detail: a rollout is triggered only when the deployment pod template changes. Updating an image or template label triggers it. Scaling replicas does not create a rollout revision. A common update is changing the image. The resource is the deployment, the container name is nginx, and the new image tag becomes part of the next pod template. After the update, get ReplicaSets. You should see the new ReplicaSet scaled up and the old one scaled down. That is the rollout made visible. By default, deployments use RollingUpdate. Kubernetes gradually scales the new ReplicaSet up while scaling old ReplicaSets down instead of deleting everything first. maxUnavailable controls the lower bound. The default is 25%, so a 3-replica deployment keeps at least 75% of desired pods available during the update. maxSurge controls the upper bound. The default is 25%, so Kubernetes may create a small number of extra pods while replacing old ones. You can make rollout behavior explicit in the manifest. A high surge needs spare cluster capacity. A high unavailable value rolls faster but accepts more temporary loss of service capacity. Official docs call out a subtle caveat. Terminating pods may still consume resources while they shut down, so actual resource pressure can temporarily exceed what maxSurge seems to imply. The other strategy is recreate. It terminates the old revision before creating the new one. That can be simpler, but it usually means downtime for stateless web traffic. If you push a bad image tag, Kubernetes still creates the new ReplicaSet. The difference is that new pods fail readiness or image pull, so the rollout cannot finish. In a healthy rolling update, old pods shrink only as new pods become available. In a failed rollout, the old ReplicaSet often stays serving while the new ReplicaSet is stuck. Describe the deployment and read conditions. Available means minimum availability exists. Progressing tells you whether the rollout is moving. Replica failure points at creation errors such as quota or permission issues. progressDeadlineSeconds tells Kubernetes how long to wait before reporting that rollout progress has stalled. The default is 600 seconds, and the value must be greater than min-ready seconds. Before undoing anything, inspect history. A deployment revision is created when the pod template changes. The old ReplicaSets hold the revision data used for rollback. The old record flag is deprecated. If you want a meaningful change cause, annotate the deployment or let your delivery tooling set the kubernetes.io/change cause annotation. You can drill into a single revision. That is useful when you need to know exactly which image, labels, and template fields you are about to roll back to. The basic rollback is rollout undo. It changes the deployment pod template back to the previous revision and starts a new rollout toward that template. When several revisions exist, be explicit. Use to revision when you know the stable version you want, then verify the deployment in pods afterward. Rollback restores the pod template from the selected revision. It does not mean every deployment field rewinds. Scaling changes, for example, are separate from rollout revisions. RevisionHistoryLimit controls how many old ReplicaSets are retained for rollback. The default is 10. If you set it to 0, you remove rollback history after cleanup. Pause is useful when you need to make several template changes. While paused, changes are recorded on the deployment, but they do not trigger a new rollout until resume. The important caveat is simple. You cannot roll back a paused deployment until you resume it. Also, progress deadline checking is not active while the rollout is paused. When the template is ready, resume the deployment and watch ReplicaSets. Kubernetes creates the new ReplicaSet and starts the usual rolling replacement. For a restart, use rollout restart. It is commonly used when pods need to restart and pick up external changes, but you are not changing the container image tag. Official docs call this proportional scaling. If you scale a deployment while a rolling update is in progress, the deployment controller distributes extra replicas across active ReplicaSets to reduce risk. Do not treat selectors as a casual update field. In app/v1, the deployment selector is immutable, and overlapping selectors can cause controllers to fight over the same pods. A practical debug path is rollout status, get deployments, get ReplicaSets, get pods, describe the bad pod or deployment, then check events and logs. Each step narrows the failure. Before a serious update, check 4 things. Do you have readiness probes? Do surge pods fit cluster capacity? Do you have logs and metrics? Do you retain enough revision history to undo safely? For a CKA-style workflow, remember the loop, apply the manifest, update the image, watch rollout status, inspect replica sets and pods, undo if the rollout is bad, and verify availability again. A deployment rollout is controlled replica set replacement. The safe operator habit is to change the template deliberately, watch status, read conditions, and keep rollback history available.